चैनल व्यू ब्लॉग में आप सभी को स्वागत है। आज हम पढ़ाने वाले हैं सब्लिमेशन। There are certain substances that change density from solid to liquid or vice versa. This phenomenon is called sublimation. Sublimation is the transition of a substance directly from its solid to gaseous phase without passing through the intermediate liquid phase. Latent heat is the energy released or absorbed by body during a constant temperature process. Heat change state solid liquid. Latent heat of vaporization energy charge change required to transform a given quantity of a substance from liquid to gas at a given pressure. The effect of pressure is negligible on solids, more on liquids and the most of the gases. When pressure is increased further, the gas particles come very close to each other and condense, consequently get converted to liquid. Change in pressure also causes change in the temperature at which a material is transformed from one state to another. So if pressure is greater than high temperature is needed to change the state of material. By increasing the pressure, CO2 can be changed to solid. Carbon dioxide dry latent heat of fusion. The energy change when a given substance is heated to change its state from solid to liquid. Latent heat of vaporization is the energy change required to transform a given mass diffusion. Stagnant air diffusion. S equal to M1 P D F equal to S and equal to K1 D upon D of electron paramagnetic resonance and electron spin resonance. Electron is a negatively charged particle with certain mass. It has two kinds of movements. The first one is spinning about the nucleus, which brings orbital magnetic movement. The other is spontaneous around its own as a spin quantum number. Every electron has a magnetic movement and a spin. Magnetic movement of the molecule is primarily contributed by unpaired electrons. Spin magnetic movement ms is equal to root mass s plus 1 upon h upon 2 pi, where ms is the total spin angular momentum in the z direction. The component of the total spin of angular momentum can only assume two possible after the 1 by 2 electron paramagnetic resonance, electron spin resonance materials with unpaired electrons. The EPR deals with the study of electron spins that are excited using microwave radiation in presence of an external magnetic field with a strong B naught. The electromagnetic field aligns itself either antiparallel or parallel. ms is equal to minus half, ms is equal to plus half, E is equal to ms G mu b V naught, where G is the electron so-called G factor, mu b is the Bohr magnet, and EH upon 4 pi m is the separation between the lower and upper state. Is delta E equal to G mu b naught. The splitting of energy levels is directly proportional to the magnetic field strength. Change electron spin by either absorbing or emitting a photon of energy. S nu equal to E delta E G mu b naught. Microwave in the 900,000 to 10,000 ms 90 gigahertz relaxation time is directly proportional upon what the EPR signal very short and speak signal are broad wiring. The microwave frequency incident on a signal while holding the magnetic field reversible constant are doing the practice. In practice, the frequency that is kept fixed is exposed to microwaves at a fixed frequency. Safe peaks are obtained by increasing the external magnetic field. The gap between ms equal to plus half and ms equal to minus half energy states is widened until it matches the energy of the microwaves. At this point, the unpaired electron can move between their two spin states. More electrons in lower state embedded there in a net transition. It is this absorption that is monitored and considered into a spectrum. The EPR spectrum is usually absorption spectrum. First derivative of the absorption spectrum, the microwave frequency of 93.2 MHz. The predicted resonance occurs at a magnetic field of amount B is equal to B naught is equal to H naught G E H mu hyperfine coupling constant of a nucleus is essentially the spacing two ion mechanism Fermi and contact interaction isotropic independent of the orientation. Dipole interaction and isotropic interaction dependent on sample orientation and magnetic field spin or polarization. Benzene radical anion pi neutron orbital the G factor information about paramagnetic centers applied magnetic field B naught B double E equal to B naught 1 minus sigma. Sigma include the effect of the local field. Sigma can be positive or negative. Pascal triangle splitting due to an equivalent asymmetric role molecule nuclei. Diffusion in solid, liquid, and gases. The methods are others so that they uniformly different among each become diffusion is based on the movements of particles and the rate of diffusion increases on increasing the temperature. Diffusion in gas very fast, faster in hot. Diffusion in liquid slower than the gas. Chemical plus water crystal CSO4 crystal plus water. Diffusion in solid very slow process became because particles are fixed. Diffusion in gas, the particles in gas are spaced out and move about very quickly in it is because the particles will each continue to travel in a straight line will each with heat. Diffusion is the random movement of gas through another primary region of high concentration. Smell of vegetables candle. The smell of the flow to fall in the room due to collision. The concentration of gas particles takes time to spread out. Bonding in solids can be classified into different categories depend upon the type of constituent particle and the nature of attracting forces operating between the primary bonding ionic metallic secondary bonding valence and hydrogen. Primary bonding ionic bonding. In this bonding the constituent particles are ions of opposite charges. These are formed by the complete transfer of electron from less electronegative to higher electronegativity. They are hard and brittle. They are soluble in polar solvent like water. They are poor conductor of electricity in solid states. Honor. However, they become good conductor of electricity in the molten state. They possess high melting and low volatile and covalent sharing of electron between two or more atoms. Characteristics they are hard and brittle. They have high melting point. It can be broken easily. Poor conductor of heat and electricity. High enthalpy of fusion. Metallic bonding sharing of electron. That shared pair of direction is not oxidized. Part of metal atoms where valence electron to the attractive force between the kernels and metallic mobile. Valence electron determine metallic bond. Characteristics of metallic bond in solids. They generally range from soft to hard, soft to very hard. They are malleable and ductile. They are good conductor of heat and electricity. Secondary bonding valence one under wall bonding. These types of bonding is found between atoms and molecules which does not have the tendency to gain iodine dipole. They are formed by induced dipole moment by external liquid nonpolar CO2 I2 CCl4 and in the hydrogen bond. In this type of bonding is formed by between hydrogen atom and a high accelerated atom like oxygen or chlorine. Dipole interaction. They are polar molecule like oxygen and thus the shared electron attracted toward the more electronegative atoms. Molecular polar, non-polar, low band conductor, non-van der Waals force, dry ice, iodine, argon, metabolic, ionic, NaCl. You can measure covalent, diamond, quartz, silica, metallic, all metallic, element, FeCu, Zn, AgU. Defect in solid imperfection. Defects in solid stoichiometric. There was no difference in formula. Now the stoichiometric defect FeO cation anion Fe 0.96 anion. Shortcut effect cation missing but anion missing coordination number. A small difference in A plus B minus positive charges. Size of cation to anion is B minus is greater than A plus negative NaCl KCl CSCl KCl. Density of mass of balloon decrease. Frankel defect no difference in formula. Interstitial side coordination have low coordination measured in AgCr, AgBl, lower difference in size. Cation to anion rho equal to mass 1 volume, no impact insulator, conductor, dielectric constant. Property Fu cation Fu0.94 anion cation equal to anion. Metal cation exchange. Cation is greater than anion. Anionic vacancy are metal exchange defect extra cation in STCL hydrogen no agent 2 plus half photon electroelectronic conductor electricity insulator semiconductor. Metal deficient anion is greater than cation in Cl plus Na and yellow is color. Impurity NaCl plus SrCl2 Sr2 plus Ag plus CdCl2 AgCl plus CdG group 14 group 15 B Al Ga C Si Ge P type conductor excess collector N type semiconductor surface chemistry charge on colloidal always carry an electric charge. The nature of this charge is the same on all particles in a given colloidal solution. The nature of this gas is the same on all the particles in a given colloidal solution. Colloidal solution can be classified into two types on the basis of nature of charge. The positively charged, negatively charged. Positive charge shows hemoglobin, negatively charged shows hydrogen metallic oxide Fe2O3.X2Al2O3.X oxide basic dimethyl methylene blue metal solution CuPAgAu metallic sulfide CH2S2CdS acid bright salts of starch. The charge on the colloidal particles rises due to the product. Example FeCl3 solution is added to hot water. FeCl3 solution is added to NaOH have absorbed Fe2O3.X2O. FeCl3 solution is added to hot water and absorb ion Fe2O3.X2O. Fe3 plus positively charged ion charge on colloidal particles. Ki solution is added to AgNO3 both AgO. The surface of the collider acquires a positive or negative charge due to the selective absorption. This layer attracts counter ions from the medium, forming a second layer. It results in the formation of combination two types of opposite charges around the collider. It results in the formation of a combustion of the two layers of opposite charges around the colloidal particle, and each card has more electron double layer. According to modern theory, first layer of an ion is equally held and is termed a fixed layer, while the second layer is mobile and is called diffuse theory. The presence of charge of opposite sign on the fixed and diffuse part layer of the opposite charge is called electrokinetic potential. Agita potential difference between fixed layer and the different fixed layer of opposite charge are called the electrokinetic potential. Agita potential. The presence of equal and similar charges on the colloidal particle provides all stability of the colloidal solution. This is because the repulsive forces between the charged particles having the same charge prefer that than aggregating when they come closer to the one another. Electrophoresis: when a solid is placed in an electric field, a colloidal particle move towards either cathode or anode depending upon the charge on them. The movement of colloidal particles under the influence of the electric field towards the cathode is called cataphoresis. चैनल को लाइक सब्सक्राइब और शेयर करिएगा दोस्तों। धन्यवाद दोस्तों।